All right, this is page 2 of the 7.3 notes, and we're going to continue solving some systems by graphing. Sometimes the equations will not be in standard form. This one, 2x equals y, is not in standard form, but that's okay. But we notice if you switch the x and the y, this is really y equals 2x. And that's really in slope-intercept form, right? And we can still make a t-chart, but make a t-chart for this line. 0 for x, we would have 0 for y, right? Now I could plug something else in for x also. If I plug in, I don't know, 1 for x, I get 2 for y. So there's a couple points, 0, 0, and the point 1, 2. Now I could choose more points if I want to, is enough though. But maybe I'll choose another one if I choose, I don't know, negative 2, let's say. That's negative 4, right, for y. So negative 2, negative 4. And those 3 points should all fall in the same line. Go ahead and graph that line. Okay. Now we have this other line, 5x plus 3y equals 0. That is in standard form. I'll make a t-chart for this one. If I put in 0 for x to find the y-intercept, we have 0 plus something equals 0. Well, this y would have to be 0 also, right? So in this case, the x and the y-intercept are the same point, 0, 0, which doesn't really help me with the other intercept. So I'd have to find some other point. And so you could play around and try to find some other point. I think if I use, let's say I use 3 for x, then that would be 15. 3 times 5 is 15 plus 3y equals 0. Well, if I subtract the 15, I get 3y equals negative 15. Y would have to be negative 5, right? It would be negative 5. So we have a point at 3, negative 5. And so you could find other points, but 2 is enough. And you can probably already tell the solution to this system because both of these t-charts had the same point. They both had 0, 0, right? And we can see they intersect, the two lines intersect at 0, 0. And that 0, 0 works in both equations. So in this case, your solution to the system is 0, 0. Again, MyLab will have these braces here for you, and you'll put the solution point inside. Alright, so let's look at the next one. So let's see, 3x plus 2 equals y. That's not in standard form. In fact, if we move the y to the other side, y equals 3x plus 2, we can recognize that's slope-intercept form, right? So let's remember how to graph something in slope-intercept form. We could use a t-chart, but let's try a different technique. 2, remember, is the y-intercept, which means we hit the y-axis when y is 2. Slope is 3 or 3 over 1, right? That means we rise 3, 1, 2, 3, and run 1. So we have a point here. And so those 2 points, we can connect them, and we have the graph for that line. Now, I have this other line, 2x minus y equals 0. So if I try to use it, that is in standard form. If I try to use a t-chart, let's see, for this guy, my t-chart, if I use the intercepts, 0 for x, well, I would need a 0 for y also, right? So 0, 0 I know is on there, but that doesn't help me with other intercepts. I could try to find another point if I wanted to. Maybe I'll use something like, maybe I'll use 2 for y. Use 2 for y, or sorry, 2 for x. Then I'd have 4 minus y equals 0. Well, 4 minus 4 is 0, so y would have to be 4. Okay, so I have a point 2, 4. Alright, so we get these 2 points here. And I'm going to connect those. Alright, it looks like they hit somewhere right around in here. But it's hard to tell, and there is human error, so we should check that point, right? What point is that? That's the point -2, -4. It appears to be -2, -4, but we should check it. Does that work in both equations? So 3 times -2 plus 2, does that equal -4? It does, right? So 3 times -2 is -6, plus 2 is -4. So it works in that one. Let's check in this one. 2 times -2 is -4, minus -4, that's +4, is 0. So that point works in both equations. Check, check. And that would be our solution set. Again, MyLab will put the braces. You don't need to put those in. You just need to have the ordered pair with the parentheses and the coordinates. Alright, so now moving on. If a system of linear equations has two parallel lines, well, we know parallel lines do not intersect, right? And if they don't intersect, that means there is no solution to the system. Okay? So with parallel lines, if we recognize two lines are parallel, we know there is no solution to the system. Now, there's a special term we use in mathematics for a system that has no solution. We say it's an inconsistent system. And those words will show up in MyLab, I believe. They'll ask you if it's an inconsistent system or if there's a solution or if something else happens. And there's one other thing that could happen. A system of linear equations, and if they consist of two lines that are actually the same line. So you can have two lines that look different as far as their equation goes, but they're actually the same line. For instance, one might be in slope-intercept form, one might be in standard form. Or one might just be multiplied by a constant from the other form. And so they're really the same line, but they look different. If that happens, if they're the same line, every point on the line is a solution. So they're really infinite solutions. And then so what we would do, if they're infinite solutions, there's a special term for that. We call that a dependent system. So dependent system means you graph a line, you graph another line, but it happens to fall right on top of the first line. So two lines are the same line. Inconsistent system means you graph a line, you graph another line, and they happen to both be parallel. No solution here, infinite solutions here. No solution, parallel lines means it's an inconsistent system. Same line means they're infinite solutions, and it's a dependent system. And we'll look at some examples of that on the next page.